Hi everyone, Mr. Ince here. Thanks for tuning in. I want to take a few minutes and discuss what I'm going to refer to as your tool belt for building proofs. We've recently been discussing different ways or methods of trying to prove that two triangles are in fact congruent to each other. There are a variety of different ways to do that. And so what I've done is literally construct, see what I did there, a tool belt of 6 pretty common tools that you're going to want to use in that pursuit. So let's go ahead and start on the left and discuss what these are, how we talk about them, how we write them, and how we can spot them. So over here on the left, we're starting right over here, is you always want to be on the lookout for a vertical pair of angles. Now remember, vertical angles are when you have two lines that cross, and they're the angles that end up being on the opposite sides of each other. So in this visual, I'm looking at the angle pair that is inside of the triangles, and so I could say that this angle and this angle are congruent to each other, and my reasoning would be that they are a vertical pair. So the way that I would write that, one option would be that angle LRA is congruent to angle NRS. And again, the reason I'm allowed to add that is that vertical angles are in fact congruent. Next up, let's take a look at what's referred to as the reflexive property of congruence. This is an idea that pops up whenever you have two shapes sharing something. They could be sharing a side or perhaps sharing an angle. In this example, I'm going to identify the smaller triangles 1 and triangle 2. And if you look close, they end up sharing side RT, meaning that RT would really be in both of those triangles if you were to try to take some scissors and cut down the middle. Now, if you think about it, RT is the same size as itself no matter how you look at it. So I'm allowed to add to this figure that side RT is in fact congruent to side RT. And my reasoning, once again up here in this box, is the reflexive property of congruence. Next, if you ever have a picture where you see these small arrows on a couple of the lines or sides, remember that means that those sides or lines are parallel. A little bell should be going off in your head that with parallel lines, if they end up being cut by a transversal, meaning a side or line that goes through, those parallel lines at two unique spots, there are different angle pairs that are formed, some of which are congruent. In this case, alternate interior angles are congruent, and those could be found right here and right here. So in this example, I would be allowed to add that angle BCA is congruent to angle GAC. And my reasoning would be that with parallel lines that are cut by a transversal, alternate interior angles are congruent. Now, these last three that we're going to discuss are kind of similar in that you're relying on the definition of a certain piece of academic vocabulary that you've probably discussed in the past. This first example, we're going to use the word bisect. The word bisect means to cut in half, or another way of thinking about that is to cut into two equal parts. In this visual, we are provided with a given piece of information that side BD bisects, keyword there, angle ABC. So you want to make sure that you identify that. There aren't really many clues that I can see at the moment, but if I recognize that side BD is the bisector of angle ABC, that tells me right away that I'm allowed to state that this angle here is congruent to this angle here. So again, I am allowed to add that angle ABD is congruent to angle CBD, and my reasoning would be the definition of bisect. Let me go ahead and scroll back up here. Next one, the definition of the word midpoint. The word midpoint literally just means the point that is in the middle of a given side or segment. So down in this visual, if you take a look at your given information, you're told that side AC is congruent to side BC. But notice, that's actually already printed in the picture. You have the single dash being congruent to the other side with a single dash. So how does this help us? If you look at your next piece of given information, you're told that M is the midpoint, keyword there, of side AB. So that tells me that M right here is the midpoint or is in the middle of side AB, which means that I'm allowed to add into this figure that side AM is congruent to side BM. So I would be allowed to write that, once again, side AM is congruent to side BM, and my reasoning would be up here in our reasoning box, is the definition of the word midpoint. Now, on to our final tool. Sometimes you'll be able to use or take advantage of the word perpendicular, or the definition of the word perpendicular. Now, to save you a little bit of handwriting, you want to make sure that you recognize that this symbol, which looks like the beginning of a game of hangman, is the symbol for the word perpendicular. The word perpendicular means two sides or lines that meet each other and form 90-degree angles. So in this example, you're given information that side MJ is perpendicular right there to side NK. So visually, you're looking at it, and it's that side MJ is perpendicular to side NK, which means that they meet, forming 90-degree angles. Now, any 90-degree angle is congruent to any other 90-degree angle. So I'm allowed to state or add to this problem that angle MJN is congruent to angle MJK, and my reasoning would be the definition of perpendicular. So there you have it, 6 pretty common tools that you may want to use in your pursuit of trying to show that two triangles are congruent. With a little bit of practice, I know that you guys can do it. So now you just got to go out there and prove it.